Hi, what's up? Have you discovered what is the universe made of? Well, I think perhaps the most correct answer is I don't know. The universe is vast, and is it expanding is fast. Thus, it's practically impossible to detail anything if we decided to use our limited eyes. And in addition to this restricted space for our observations, we need to take in our minds that every moment in this expanding, new things arise. Oh, you might think I'm messing you up or saying random things because nobody has discovered anything yet or knows anything, but that's the idea. Day after day, the humanity advances beyond the limit of the knowledge. But it turns out that each discovery thoroughly studied exhaustively can only explain measly 5% of the composition of the universe. It's like you discovered you received an inheritance of $5 million from a wealthy great uncle you didn't even know. $5 million. But someone tell you that it was only $250,000. Maybe you even thought it was too much, even though your money was zero before. But what about the other part? What about you could do with this part? It may even be an absurd and meaningless example, but that is the logic. The human mind was able to deduce amazing things, just as $250,000 would do miracles. But knowledge is still restricted to 5% in the middle of an enigma about the other 95. Is it important to remember that with each discovery, this percentage changes, but the proportion is still equivalent? Now that you know that all we know is approximate 5%, I must say that in fact this 5 is 4.6%. In this part of percentage, we find the conventional matter. This type of matter is formed by protons, neutrons, and electrons, and what is called baryonic matter. So we call baryonic a particle what is made of 3 quarks. I told you about the 4.6%, and now the other 0.4 is about neutrinos, photons, heavy elements, and others. In the 95% puzzle, the researchers contributed a lot, but it still needs some questions about the approximate 25% of dark matter and the 70% of dark energy. Well, we know that this is the equivalence and we have methods to prove it, but we still don't know much beyond the basic information of characteristics and composition. There are many speculations and few experiments to show the interactions of these two factors, but not yet something that successfully could create or reproduce this type of matter, nor the energy. In fact, the dark energy is less known. In a more primitive universe, the ratio was made between neutrinos, photons, and atoms of dark matter, and this one was like 63%. Well, I talked a lot about this mysterious matter, so I'll go ahead with this. The dark matter at first does not behave like the baryonic matter we used to. It's kind of complex, but the particles in this type of matter is not like the protons and neutrons. They're not positive or negative, they're totally neutral. Because of this, the dark matter doesn't have any interaction with the electromagnetic force, one that the 4 fundamental forces of nature. Another property is there is no radiation emission, and about the light there is no absorption or reflection, so the dark matter doesn't interact with the light too. So hence the name, that's why we call dark, because if there is no interaction with the light, we can't see anything. And that is why it's super hard to identify, study, and understand better about this type of matter, because it's like something that is invisible to us. In general, observations for study need to capture some type of light or radiation, and since dark matter doesn't do this, doesn't interact with the light or anything, is it impractical. But even with this difficulty, it was discovered by indirect means, that is, interact gravitationally. Even without understanding its properties, we know the dark matter exerts some type of gravitational force, another of that 4 fundamental forces. There is a calculation of a rotation of a galaxy that suggests a certain amount of mass for a certain speed. Then it was detected that there would need to be more mass to reach the turn that was being seen. Okay, let's see. Galaxies work like solar systems, attracting bodies to orbit them. So this rotation of the galaxy is nothing less the orbital speed. So you can deduce that the higher speed to orbit something means the greater gravity attracting, and greater the gravity, greater the mass needs to be. The fact is, you would need a much larger mass than you can see in this experiment. When Fritz Zwicky weighted a galaxy and saw that the total mass was like a 400 greater than the visible, the dark matter was discovered. And now, the dark energy. Well, dark energy, we know that is the main influence of the expansion of universe. In the past, the researchers thought that the expansion of the universe was in a slower pace because of the gravitational effects. Like you throwing a random object in the air and it is stopping until it returns to your hand. But only after a few studies they found the more a universe expands, more fast it does it. The years passed until they came to the idea of the dark energy, and what is known is that this dark energy fills all the space. The thing is even in this nothing, there not really exists this nothing. This empty space is filled by a dark energy. And while it works in a repulsive way with gravity, that is, it doesn't matter if there is gravitational force through the space, it will not slow down and attract the ends of the cosmos. Because dark energy interacts repelling. It is precisely what makes the universe expand in an accelerated way. The universe and its mysteries. Well, do you remember about the 5% that we know? Tell me about this. Is it infinity? Renewable? How did we get to all the elements of the periodic table if in the beginning a large part of the universe was only hydrogen and helium? Wait for me. I'll wait for you on the next video.